This is the second video of the topic about UniFi WAN versus VLAN DNS server settings. If you missed the first video, I strongly recommend you to watch that one first, because in the first video, I discussed how the WAN DNS server setting and the VLAN settings, they impact the backend configurations and how they work together. So in this video, I will directly jump to the different scenarios. Nowadays, in our local network system, the DNS-related settings are becoming more and more complicated. If you use UniFi router, just on the UniFi network controller, you can set the DNS server on the WAN part, or for each VLAN, in the DHCP setting, you can set the DNS server. And if you use Cloud Key to run the network controller, later you will see it use totally different ways to support name server. And then within your UniFi router, you may know it runs DNS mask to support the local DNS service. Then in your client machine, different system has different ways to customize or override the DNS server setting. To make things even more complicated, some people will run Pi-hole to provide DNS name resolving. You need to set upstream DNS server in Pi-hole, or some people will even run Unbound, and then in Unbound you need to configure the DNS forward. So these are just several examples about where you can make DNS server settings. In this video, let's explore several selective scenarios. Before exploring the real scenarios, let's first discuss a very special case. Sometimes you will observe some ghost DNS queries. When I say ghost, I mean you don't understand where the queries come from, why they even use some specific DNS server, because you never set it to do so. Let me show you the symptom, then let's try to find out what's the reason. In my lab environment, in the network controller setting for internet, for the primary WAN part, the default setting for DNS server is author. Let me change it to, let's say, 9999. Okay, apply changes. Then in the lower part, I have a Wireshark as shown on the diagram. The Wireshark is monitoring the WAN part, not the LAN part, because I want to see what's the ultimate DNS queries going out of the router. So let me start capturing. I already set the DNS as the display filter. So you can see I haven't done anything about DNS queries, right? Then there are a whole bunch of queries happening already. So the source is from the router's WAN part, and the destination is 1111 or 8888. And it happens so frequently, but in my network controller setting, I set it to 9999. You already saw it, right? I never expect any queries against these two servers, because theoretically no clients even can know the existence of these two servers. Where these strange DNS queries come from, let's find it out. So in the left side, let me SSH into the router. So the right side Wireshark is only showing the packets from the WAN part perspective. Now I'm in the SSH into the router, so I have the opportunity to show the packets for any interfaces within this router. Let me simply run a TCP dump for interface. I say any. I want to capture all the interfaces traffics. I need to filter the port to 53, which is for DNS. So let me write. You can see the busy DNS traffics just within the router. And if you compare the left and the right side by side, whenever in the right side you see queries against 1111 or 888, in the left side, let me kill the TCP dump so you can examine the captured frames carefully. Let's examine this example packet. So see, the interface is Ethernet 3. For UX3 Pro router, the Ethernet 3 is the fourth port, is for my LAN part. On my LAN part, there's a in packet, and it is from this particular machine, and the destination is the 1111, right? Then we simply need to find out what's this machine. Before the dot is UniFi. After the dot is internal -1. I know for my default network, I set the local domain name to internal -1. So that means this particular machine is within my default network. Then the host name is UniFi. You may know for UniFi network controller, it keeps the hard-coded host name for the machine which runs the UniFi network controller. So in my case, I use CloudKey Plus. So my CloudKey Plus has the UniFi as the host name. I do have a video in my channel talking about layer 3 adoption for UniFi network. It is related to this UniFi domain name thing. Just from this information, I already know the troublemaker is the CloudKey. But even if UniFi host name thing doesn't ring a bell, you can still easily find it out what's this domain name for. Let me go to this DNS mask config.d folder. And within the folder, there's a file called DNS config. Let me display it. You can see this host record settings. So they have the host name UniFi. The same machine has different host records in different VLANs, but they all have the same IP address. I know this IP address is for my CloudKey. This is just another way to identify what's the UniFi host name for. Okay, so now we know it's the UniFi CloudKey which did all the ghost queries. So why the router's DNS configuration doesn't impact the CloudKey, why the CloudKey is still using the 1111 or 888 to do some strange DNS queries. Let's go to the CloudKey to find it out. Okay, in the right side Linux session, let me SSH into the CloudKey. The CloudKey is also running a Linux. In order to find out how the name resolving works, we first check this Linux configuration file. It's pointing to this strange IP address. Apparently, we already see it's working differently than UniFi router. So let's continue looking. Let's see what's happening on this IP address. Let me run the standard Linux command netstat. Try to find out who's listening on the port number 53. Okay, only several of them. The very first line is already the answer. You can see this process name, systemd resolve. It is listening on the port number 53. This process is providing the name server service to this CloudKey Linux. If you are not familiar with the process name, it's for the resolve D, part of the systemd. So it's a service to provide network name resolution to local applications. If you watched my first video, you may remember for UniFi router, it used DNS mask. But apparently for CloudKey, it's using different technology. It's using the systemd resolve D. To find out the resolve D configuration to see what's the external name server it used, we need to go to the system configuration. So for resolve D, the default configuration folder is under etc systemd resolve D config.d folder. Let me cd to it. No, it doesn't exist. Then let me try systemd. Okay, this folder exists. What's inside? Okay, apparently Ubiquiti decides to directly put the configuration file under the systemd. Let's see what's inside the resolved.config. Okay, it's super simple. It specifies the DNS servers. That's why we see those ghost DNS queries. They are not ghost at all. They are simply from the CloudKey, and the CloudKey is not following what we set in UniFi controller. It has its own hard-coded name server. So we are clear about this special scenario. The reason I want to discuss this first is in all the following scenarios, you will see those annoying 8888 1111 DNS queries. Without having it discussed, we will have difficulties to understand the real crucial traffics. So we are done with this one. Let's move on to the first scenario. In this scenario, we keep all the settings default, which means on the LAN part, it's alter DNS server. For the VLAN, we also keep the setting alter. So in the right side in UniFi network controller, let's make sure for internet, for the primary WAN part, I revert back the DNS server setting so that it's alter. Then from VLAN, for example, this VLAN 10, let's double check. Yes, for DNS server is alter. So now it's alter settings all the way. Then in the Wireshark, as you can see, the Wireshark is running here. It's monitoring the router's WAN part. Okay, start capturing. Then in the lower part, from the VLAN 10 Linux client, let me dig x.com. Something's captured. Let me stop it. Let's examine what's captured. This source IP address is the router's WAN part IP address. First DNS request is sent to this IP address. Before we continue, let me show how my lab network works. As you can see, my home lab is behind another router. This main router is sitting in my home network. This main router has a VLAN. It has this .2 subnet. My home lab's router, the UXC Pro, the WAN part is connecting to this home network's .2 subnet. So that's why the WAN part, the internet IP address for my home lab, is in the .2 subnet. Okay, just to explain why you see the .2.1 IP address, because that's the IP address for my home network's router. Hopefully it's clear. Go back to the first scenario. So the first DNS query is sent to my home network's router. That makes sense. Later we will check the backend configuration. But you can see this strange DNS query. It's sent to 1111. I never set my external DNS server to 1111. I simply keep it author. Then why the system did this separate DNS query? And then later you can see from my home network's router, it did reply, and from the 1111, it replied as well. So we have two things to clarify. First, where this .2.1 information is configured in backend. Second, where this second DNS query to 1111, where it comes from. In the SSH session to the router, I expect a DNS mask configuration file under etc. Let me list it. Okay, so in fact, this file is simply a link to this file. Now it's clear because we see both DNS servers. Let's try to understand. So first, you see the comment is dynamic name server and it's for the WAN part. And the server is my home router's IP address. So in UniFi Network Controller, for the WAN part, you can see for IPv4 configuration, I choose the DHCP, which means the WAN part for my router get the IP address and the DNS server automatically from the upstream server. In my case, the upstream server is my home network. It makes sense. We receive this dynamic name server. And then for this 1111 thing, the comment says it's static name servers, which means when you configure the WAN part with DHCP, the system will automatically add this so-called static name servers. I don't like it. In my opinion, it's not good. Without letting the users know, the UniFi router is leaking the user's DNS queries to 1111. It may be a problem to some users. It may violate their policies. If you have any insights about why Ubiquiti even include this 1111 as the static name server, why this one cannot be simply removed, please let me know in comment. Another thing I want to point out is by default, if your system has two name servers, so in our case, we have the 0.2.1 and the 1111, right? If the first one serves the DNS query successfully, the second one won't be used at all. But why in our case, the system automatically queries both name servers? The reason is in the DNS mask configuration. The DNS config file. See this particular setting, all servers. By setting this flag, it forces DNS mask to send all queries to all available servers. But the reply from the server which answers first will be returned to the original requester. That's how the system works. Before we move on, let's examine the client machine one more time. See this right side VLAN 10 Linux client. Because we set the router's VLAN 10 DHCP to author, which means the Linux client will also receive the DNS server configuration. Let's validate what's the current value. Go to the wired settings. See the DNS is this .10.1, which is my router's VLAN 10 IP address. right? Internally, the router uses DNS mask to forward the DNS query to the real external DNS name resolver, which are these two, .2.1 and 1111. It's all clear about this very first scenario. Let's move on. In the second scenario, let's manually set the client machine's DNS server setting. So in this Linux machine, go to wired setting. Then under IPv4, let me say menu for IP address. Give it this subnet 10 IP address, net mask. For gateway, give it the router's IP address. Then for DNS, let me remove the author. Then hardcode to 8888. Okay, apply settings and force the refresh. So now in the client, we have hard-coded DNS server. At this time, the router's DNS server settings don't matter anymore. It doesn't matter whether we have author or we manually set it. They won't be effective. Let me show you. So in the Wireshark, let me start capturing, and then in the SSH session to the router, let me run TCP dump, and the interface Ethernet 3.10, which is for VLAN 10. Then for port, let me say 53, run it. Okay, so I'm running two parallel packets capturing, one on the WAN part, the other one on the LAN part, more specifically for VLAN 10. In the client, let me do the same, digx.com. Okay, let me stop capturing. Let's examine the WAN part Wireshark capturing first. From the router's WAN part to 8888, and the reply is from 8888. You don't see the queries to 1111 as in first scenario because the UniFi router's DNS settings are not relevant at all in this scenario. Then in the SSH session, let's see what's captured for VLAN 10's LAN interface. The request is from this Linux machine and the destination is Google, then reply is from Google. So basically the same information as we see in one part. Right? This scenario is very simple and the complete end-to-end process makes sense. There's no surprise. The system strictly follows what we set in the client side. In scenario 3, let's manually set the external name server in VLAN's DHCP server setting. So let me go to VLAN 10 for DNS server. Let me say 8888, apply changes. Then for the client, let me go to the wired setting. This time, let me use DHCP. I don't want to do manual for this scenario. Apply changes, refresh DHCP. Let's check what's the new setting. See the DNS is 8888. It comes from the router from VLAN 10. For this scenario, the one part DNS setting doesn't matter at all. Similarly, I launched the Wireshark for one part, and in the SSH for UX3 Pro, run TCP dump, monitoring the Ethernet 3 VLAN 10 port. Then go back to the Linux client. Let me dig the same domain name, x.com. Something happened in both capturing sessions. See the Wireshark, the router from the WAN part send the DNS query to 8888, and then it doesn't send the request to anyone else. You don't see 1111, right? It makes sense from the Wireshark side. Then let's check the SSH session. So you can see this one from this Linux machine. I can tell from the host name and the local domain name, right? The destination is directly Google. It's not the UniFi router, right? And then the Google directly replied. So everything makes sense. The whole process works as expected. But this scenario has a problem. The problem is not about the external internet domain name. It's about your local domain name. For example, for this VLAN 10 in the DHCP setting, I set its local domain name to be vlan10.home.apa. But because I manually set the DHCP server for VLAN 10, the client will bypass the DNS mask for VLAN 10. Which means whatever I set here won't be effective anymore. Let's validate it. So from the Linux client, let me dig itself. Debian10 is its host name, and this part is its local domain name, right? Let me dig it. See, it got result back from Google and the answer count is 0. Of course, Google doesn't know the IP address for my local machine, but in fact, UniFi router does know that. You can even tell from the left side SSH session. See this one? The system knows the domain name for my Linux client, but because the Linux client bypassed the UniFi router, that setting is not effective. Why the client bypass it? We didn't force it to bypass it. It's simply because we changed the VLAN DNS server, and then the Linux client derived the change from DHCP. Okay, so this is one potential problem if you choose this way to change the DNS server. For scenario 4, instead of changing the VLAN DNS, let's change the WAN parse DNS server setting. So in the right side UniFi network controller, for VLAN 10, let me change the DHCP server back to author. Then for the WAN part, primary internet, change the DNS server to 8888. Apply changes. Then from the Linux client, let me refresh the DHCP setting. Disconnect, reconnect. See, the DNS server is .10.1, so it is the UniFi router. Even though in the WAN part we already changed the DNS setting, it doesn't impact our VLAN 10's DNS server setting. The Linux client still treats the router as the DNS server. So internally, the router will run DNS mask. It will forward the DNS query to external DNS name server. Then let me restart the capturing in Wireshark and in SSH. Run the same dig command, digx.com, stop capturing. Let's see what's captured in Wireshark. So there's only one request from the router to Google, and Google replied back. No surprise. Then if we check the SSH, this time it's different than previous scenario. See, the source is still the Debian 10 Linux client, but the destination is not Google. The destination is the router itself, because DNS mask is running on this IP address to act as a local DNS name resolver. And then even the reply is coming from the router, not from Google. So internally, the router is doing the forwarding. Okay, so all the traffics make sense. And in the end, see the Linux client, it got reply back from this DNS server, which is the router. So the Linux client doesn't know the existence of 8888 at all. It doesn't care. It directly talks to the router. Okay, then let me restart the capturing. This time, let me dig the local domain name. Okay, stop capturing. See the Wireshark, there's no DNS query at all about this dig. Why? Because the UniFi router knows this domain name is a local domain name. It didn't bother asking Google. It directly handled it internally within the DNS mask. And then in the left side, in SSH, you can see the similar DNS query asking the VLAN 10's DNS local server. And then the DNS mask replied. In this scenario, both the internet domain and the local domain work. If you compare this one with the very first scenario we test, remember in the scenario 1, we see a strange, annoying DNS query to 1111, right? But this time, we don't see it. Why is that? Let's check the DNS mask resolve configuration file. Let me display this configuration file for DNS mask. See, this time it only has one entry and the comment says static, because this time we are not relying on the DHCP for the WAN part. We hardcode the DNS name server. That's why it has only one entry, and this entry is already a static name server. It doesn't have dynamic name server because it already has a static entry. The system didn't add the additional one, which is 1111. That's why we only have one active external name server which is 8888. The very last scenario for this video, let's see what if you use Pi-hole. In this configuration, I have a Linux machine running Pi-hole and Unbound. And in the Pi-hole configuration, you can see its upstream DNS server is pointing to Unbound. And in the right side, let me show you the Unbound configuration. So the configuration file is named piehole.config. It's under this folder. Display it. It's a very simple configuration file because in this particular server, I simply enabled the DOT, DNS over TLS. So in forward zone, I use Google to forward the DNS query to. So it's very simple, straightforward setting in Pi-hole and Unbound side. Then let's see how it works in UniFi. Of course, in UniFi network controller, I need to revert back the one port setting, even though it really doesn't matter in this case, but I still want to make it alter. Then go to network. Let me use VLAN 10 as an example. In the DNS server side, I need to use the Pi-hole server's IP address. So let me find it out. Okay, .10.135. Apply changes. Then because we changed the VLAN 10's DNS server, I need to refresh the DHCP in the Linux client. Let's check the current DNS server. See, it's from the Pi-hole server, right? Let me start capturing in Wireshark. Let me first dig x.com. You see nothing's captured in Wireshark. Why? Remember, I used Unbound and I enabled DOT. So now the DNS queries are not using DNS protocol anymore. It's using the TLS. So let me change the display filter to TLS. Okay, so now you see the query is from the router to Google and it's in TLS. All the packets are the encrypted TCP communications. I have no way to see what they are talking about because they are in TLS protocol. And then see the Linux client. It got result back from Pi-hole and it got the correct result back. If we choose to dig the local domain name, let's try it. Let me enable the Wireshark very quickly, then dig it. See, nothing's captured. Pi-hole plus Unbound is smart enough because this domain name is a local domain name. They didn't send the query to Google. Okay, this is the end of the video. It's a very long one, back and forth changes. Thanks for watching.